Let's explore the concept of limiting reagents. Here's a recipe for making water. Okay, your balanced equation is like a recipe. So my question is, how many moles of water are you going to get if you react 10 moles of hydrogen gas and 7 moles of oxygen gas? Notice that I provided two numbers for both the reactants, and I'm asking you to calculate the amount of product. This is a limiting reagent problem, okay? Anytime amounts of both reactants, any two reactants are given to you and you're asked to calculate the product, this is a limiting reagent problem, and I'm going to explain to you just in a bit what that means. So as you can see, hydrogen and oxygen react in 2-to-1 ratio, and as you can see here, the ratio is not 2-to-1. So one of them is going to react completely and the other one is going to be left over. Okay, the one that reacts completely is called the limiting reagent. The one that reacts completely is our limiting reagent. And the reactant that is left over is called the excess reagent. The excess reagent, or you can say the excess reactant. Okay? So you have seen the nuts and bolts analogy. So let me expand on that a bit. So this time I'm going to choose a different analogy, the bread and cheese analogy. So here's the recipe for making a sandwich. This is like your balanced chemical equation, okay? And the recipe is you put 2 slices of bread and 1 slice of cheese together to make one sandwich, and sandwich is your product here. So think about it. How many sandwiches can you make? Suppose I have 6 slices of bread and 4 slices of cheese. Think about it for a moment. Okay, here's the answer. If I have 6 slices of bread, let's calculate how much cheese is needed, okay? For 2 bread, you need 1 cheese. So for 2 bread, you need 1 cheese. That means for 6 slices of bread, you need 3 slices of cheese, okay? And as you can see, let me write needed here, is needed. And as you can see, you have 4 slices of cheese. This is what you're beginning with. This is what you have, okay? And since you have more than what you need, you can use up all the slices of bread, okay? Your bread runs out first, okay? So since you have more cheese than you need, your bread is going to be bread runs out first, okay? Bread runs out. That means you can say bread is used completely, okay? And bread is used completely, so you can use up all your bread. So how many sandwiches will you make? As you can see, the ratio is again 2-to-1 here between bread and sandwich. So if you use all these 6 bread, you're going to make for 2 bread, you get 1 sandwich. So for 6 bread, you're going to make 3 sandwiches. Okay, this is your answer. Okay, so with 6 bread, you can make 3 sandwiches. And cheese is going to be left over because you need only 3, but you have 4. And cheese will be left over. So you can say cheese is left over. And how much cheese is left over? Well, you figured out 6 bread will take only 3 cheese, but you have 4 to begin with. So subtract what is used up, the cheese used up, from the cheese that you started out with. So 4 minus 3. So that means 1 cheese will be left over. Okay, so this is the concept of limiting reagent. Always one of them is going to be left over and one of them is going to be used up completely. And we are going to, the amount of product formed, and the amount of product formed is always determined by the reactant that runs out first. Okay, as you can see, 2 should give 1, so 6 gave 3. Okay, if you calculate it from the cheese, 1 cheese should give 1 sandwich, so you can expect 4 cheeses to give 4 sandwiches, but you won't get 4 sandwiches because you won't have enough bread to go for 4 cheeses. Okay. All right. How do we expand this to molecules? Here's a similar problem, but this time with molecules. And our balanced equation is the recipe. This is telling you that 2 hydrogens would need 1 oxygen and it will produce 2 water molecules. So when you begin the reaction, let's say you have 10 hydrogens and 7 oxygens. How would you estimate how much water will be produced after the reaction? So let's calculate. Let's do this similar to what we did in the in the sandwich problem. If you have 10 hydrogens, since 2 will need 1 oxygen, 10 will need 5 oxygens. Do you have 5 oxygens? Yes, you have more than 5 oxygens. That means all your hydrogen can react. So 10 hydrogens are going to react with 5 oxygens, and then they will produce water according to the ratio. Okay, so 10 hydrogens can react completely. I'm going to write this here. 10 hydrogen can react completely since there is enough oxygen. And this is called the limiting reagent. Whichever reacts completely is called the limiting reagent. And 10 should produce 10 waters because the ratio is 2 to 2. 2 will produce 2. So if 10 react completely, they should produce 10 waters. So you're going to get 10 waters. Okay. You always estimate the amount of water from the one that reacts completely. We know that oxygen cannot react completely because one will need 2, one oxygen needs 2. So 7 will need 14, but you don't have 14, you only have 10 hydrogens. So there is not enough hydrogen for the oxygen to react completely. So this won't react completely. This will not react completely. Okay? Only 5 out of these will react. And the one that does not react completely is called the excess reagent. Because it's present in excess, 10 hydrogens need only 5, you have excess oxygen here. So how much oxygen will be left over? Since we need only 5, 5 will react, so 2 will be left over. So out of 7, 5 reacts, 2 is left over. So at the end of the reactions, in this box, you're going to have 10 products, and you can count them, 10 water molecules, and then 2 oxygens. The red ones are here are oxygens. 2 oxygens will be left over after the reaction. Okay, so given any limiting reagent problem, you can look at, okay, if I react this completely, how much of the other reagent do I need? And then you can check, do you have that much? If you do have, then yes, your previous one can react completely, and then you can use stoichiometry, the ratio, to estimate the product. Okay, I'm going to give you another way to figure out limiting reagent. This is an easy way, and we're going to use this for all our problems. Okay, so here's a simple way to figure out which one is the limiting reagent. What you do is you're going to calculate the reactions. Okay, the way you do it is, so you have 10 hydrogens here, and 2 hydrogens will run one reaction. Okay, so 2 hydrogens will produce one reaction. So 10 hydrogens should give you 5 reactions. Now let's do it for oxygen. You have 5 oxygens, and from the ratio, 1 oxygen will produce one reaction. So we can say 1 oxygen produces one reaction. So 5 oxygens will produce, I'm sorry, you have 7 oxygens. You don't have 5, you have 7. So this should have been 7. Okay. So 7 oxygens will produce 7 reactions. This can never happen though, because after 5 reactions, hydrogen is going to run out. So you never can produce 7 reactions. Okay? So always the lowest of these two answers is going to decide which one is the limiting reagent. So 5 is the lowest out of these two, and the one that gave you the lowest answer is your limiting reagent. So as we saw here, hydrogen was our limiting reagent. Let me repeat. What you basically do is you divide the number of molecules. If you have moles, you can just use moles here, okay? So you divide moles of molecules by the coefficient. So here it's 10 divided by 2 because 2 is the coefficient for hydrogen, 7 divided by 1 because 1 is the coefficient for oxygen. And then you look at which one is giving you the lowest answer. The one that gives you the lowest answer is your limiting reagent, okay? We can do the same here. In the next problem, you're going to see a problem where you're given grams. You can change grams to moles, divide by the coefficient, and figure out which one is the limiting reagent. So let's look at a problem now. Silicon nitride is a very hard, high temperature resistant ceramic used as a component of turbine blades and jet engines. It's prepared according to the following equation. So this is the recipe or the balanced equation to make silicon nitride. What is the limiting reagent when 2 grams of silicon and 1.5 grams of nitrogen react? You immediately know this is a limiting reagent problem because amounts of 2 reactants are given to you. Okay? All right, let's proceed. You're also asked to calculate grams of the product. Okay? And you're also asked to calculate grams of the excess reagent. That means one of these is going to be left over, and you're asked to calculate how much of one of these is left over. Okay, so let's start thinking about this problem. First, we want to do a calculation to figure out which one is the limiting reagent. Remember, to find the limiting reagent, you have to first go to number of things or moles, okay? So you want to change these grams to moles, and then you want to divide by the coefficients, okay? This 3 to 2 is a molar ratio. So before we use the molar ratios, we just want to turn everything, the grams to moles, okay? And then the next step would be you divide the moles by the coefficients, and whichever is the lowest gives you the limiting reagent. So here's our first step. I'm going to convert grams to moles. So let's get the periodic table out. And here I've already calculated the molar masses of silicon, nitrogen, and silicon nitride, okay? So let's get rid of the periodic table. We don't need it anymore. So start converting grams to moles. We have 2 grams of silicon, and the molar mass of silicon is 28.09. So we just divide by 28.09 because 28.09 grams is 1 mole. Okay, so we cancel out grams and go to moles. You can do exactly the same thing for nitrogen. Okay, so you start with what you have. You have 1.5 grams of nitrogen, and you're just turning this to moles by dividing by the molar mass. Okay, so molar mass of nitrogen is 28.02. So 28.02 grams of nitrogen is 1 mole of nitrogen. Grams cancel and you're in moles. Next step is you divide by the coefficients. So dividing is the same as writing the number in the denominator. Okay, so I can write this whole moles divided by 3. Okay, I'm going to put it along with the unit. 3 moles of silicon. Same thing for the nitrogen. You're dividing by the coefficients of nitrogen in the balanced equation. So that's 2. So we are dividing this moles by 2. I'm going to write 2 moles nitrogen in the denominator. Okay. Now let's calculate until now what we get. Turns out For the top part, the top part gave me, means this whole calculation, okay, until this far. It gave me 0.0237, okay? And this bottom calculation, 1.5 divided by 2.8 times 2, that gave me, let me write the answer here, 0.0267. Okay, and the one that produces the lowest number is your limiting reagent. We got a lower number here. Okay, this is lower than that. So since silicon is producing the lowest number, silicon is your limiting reagent. So that's our limiting reagent. Silicon is our limiting reagent. So what is nitrogen? Nitrogen is an excess. Nitrogen is the excess reagent. Okay. The logic is these numbers are giving you moles of reactants. You could have written 3 moles silicon is 1 mole reaction. Okay. So 3 moles silicon is 1 mole reaction. So this number is basically moles of reactions that you will run using 2 grams of silicon. And this number is telling you the moles of reactions that you will run using 1.5 grams of nitrogen. Okay, now once you produce this many moles of reaction, silicon runs out. So there is no way you can produce that many moles of reactions. Okay, so the one that produces the lowest number of reactions is the limiting reagent. So silicon will be our limiting reagent. So first part done. Next part, how much product, so this is your product, how much of the silicon nitride will be produced. So you have to estimate if I use up all these 2 grams of silicon, okay, that's the limiting reagent. So if I use up all this, how much silicon nitride is produced? So basically, you can continue this calculation, okay? You've already converted grams to moles. And now use the molar ratio to go from silicon to silicon nitride. So we already have 3 moles of silicon on the bottom. It is nicely written to cancel out our moles of silicon. And we are going to silicon nitride. So 3 moles of silicon will produce 1 mole of silicon nitride. So I'm going to use that ratio. And that's going to give you moles of silicon nitride, but we are asked to report it in grams. This let's convert it to grams. Okay, usually if it is asked to grams, you have to convert it to grams. Okay, let's say this problem is asking you in grams. Okay, let's do one more step. Moles of silicon nitride to grams of silicon nitride using the molar mass of silicon nitride, which is 1 mole is 140.31. So 140.31. And if you do this entire calculation, that will give me 3.33 grams of silicon nitride, rounded off to 3 sig figs because you have 3 sig figs in your original measured numbers. Okay, so we have basically estimated how much of the product we get when we use up all of our limiting reagent. Okay, we are not going to estimate the product from the excess reagent because excess reagent by definition does not react completely. So it doesn't make sense to do this calculation from the excess reagent. Okay, so this is not used completely. So you think of this as we don't need this calculation. Okay, you don't need to, once you do this part, once you divide by the coefficients, that's it. Don't use this calculation again. Okay, calculate your product from the limiting reagent, always from the limiting reagent. Okay, second part is done. Now third part, how much of the excess reagent will be left over? What is the excess reagent? The nitrogen. Okay, nitrogen produced a bigger number here when we did the ratio. So nitrogen we determined was the excess reagent. So the question is how much of it will be used, and how much of it will be left over. Okay, so 1.5 is what we started with. We have to calculate how much of this is used. So since we know that the limiting reagent is reacting completely, you can go ahead and estimate for when this much silicon reacts completely, how much nitrogen is it using up? Okay, so let's go ahead and do that. So we are going to calculate. So we have 2 grams of silicon. That's our limiting reagent, and we know it's used completely. So if 2 grams of silicon is used completely, we're going to estimate, we're going to calculate how many grams of nitrogen was our excess reagent, how many grams of nitrogen is used first, okay? And you can do that using stoichiometry because 3 moles uses 2 moles. So first, let's convert this again to moles now. So 2 grams of silicon's molar mass is that, and you can convert to moles of silicon. And then you can use the molar ratio now. 3 moles of silicon uses 2 moles of nitrogen. So I'm going to go from 3 moles of silicon because I want to cancel moles of silicon and calculate how much nitrogen is used. 3 moles uses 2 moles nitrogen. Okay, write the word use because you don't get confused that way. Okay, what you're calculating is how much is used. This molar ratio is telling you the ratios in which they are used. Okay, all right. Now we are going to turn moles of nitrogen to grams of nitrogen. And the molar mass for nitrogen is 28.02 grams. So 1 mole nitrogen is 28.02 grams. Moles of nitrogen cancels out. And that's going to give me 1.33 grams. 1.33 grams of nitrogen is used. Okay, we are asked for how much is left over. So out of the 1.5, 1.33 is used. So you can subtract those two and calculate the amount that is left over. So nitrogen leftover will be initial, which is 1.50 grams, minus the amount used, which is 1.33 grams. And that's going to give me 0.17 grams of nitrogen left. Okay, that's how you calculate the amount of excess reagent that is left over. So let me recap. First, when grams are given to you, go to moles, divide by the coefficients, whichever is the lowest tells you which one is the limiting reagent. Once you figure out limiting reagent, note that the other reagent, the other reactant is always called the excess reactant. Most students think the product is the excess, and that's not right, okay? The other reagent, the other reactant is the excess reactant, okay? Now, once you figure out the limiting reagent, you can do a stoichiometry, grams to moles, moles to molar ratio, and then once you have moles of the product, convert it to grams and figure out the amount of product formed. If you're asked for how much of the excess reagent is left over, again, use the limiting reagent and calculate how much of the excess reagent is used in order to react with all of your limiting reagent. And once you know how much of the excess reagent is used, subtract that from the original to get the amount left over. Here's problem number 2. Stop the video at this point and try to work this problem by yourself, and then come back and look at my solution. So here's how to work this problem out. So you can see you have a recipe for the reaction. It's a balanced reaction. And you're given 10 grams of aluminum and 15 grams of sulfur. So you automatically know this is a limiting reagent problem because amounts of two reactants are given to you and you're asked for percent yield, okay? And the problem also tells you how much of the product you measured when you reacted 10 grams of aluminum and 15 grams of sulfur. So this number is measured. That means this is the actual yield that is produced when the student has actually done the reaction in the lab. Now, to calculate the percent yield, you also need the theoretical yield. That means the amount of product calculated. And you can go ahead and do some stoichiometry to calculate this. First, we need to figure out which one is the limiting reagent out of these two. So to figure out the limiting reagent, we always convert our grams to moles, and then we divide by the coefficients and look at which one gives us the least number. So here are the molar masses of different substances listed. So you can use those to calculate to moles. So aluminum's mass divided by the molar mass gives you moles, and then I went ahead and divided it by the coefficient. Listing it in the denominator is the same as dividing by 16. You can do the same for sulfur 8. Find moles, divide by the coefficient. When you calculate the answer for this calculation and this calculation, you get these two numbers, out of which 0.0195 is the lowest. And that tells me that S8 is the limiting reagent. So sulfur is the limiting reagent here. Okay. By the way, I want to quickly recap that what you have calculated here is moles of reactants. So these numbers are basically representing how many reactions you get. Okay, this is the how many moles of reactions. Okay, and as you can see, if you want, you can write 16 aluminums will give one reaction. So 16 moles of aluminums are going to give 1 mole of reaction. So you could have written 1 mole of reactions here if you want. Okay. So what you were calculating, these numbers are moles of reactions. How many reactions you can run if you have 10 grams of aluminum, and how many reactions you can run and when you have 15 grams of sulfur. Okay. And the lowest is always possible. The highest number of reactions is not possible, because once the lowest number is done, aluminum is going to be run out. Okay. So just know what you're calculating from these numbers, and it is telling you the number of reactions. Okay. All right. So once we figured out our limiting reagent, we can proceed to calculate the amount of product from the limiting reagent. So S8 is your limiting reagent. I'm sorry, I should have, it's not aluminum. This is the wrong arrow. S8 is the limiting reagent. This is the one that's used completely. Okay, so we are going to, we already turned to moles. So now we use the molar ratio between S8 and aluminum sulfides. That's 3 to 8. So 3 moles of S8 will produce 8 moles of aluminum. And now you can change it to grams of aluminum using the molar mass. And as you can see, all the units cancel out. Moles of S8 cancels out, moles of aluminum sulfide cancel out, and you're left with grams of aluminum sulfide. And if you do this calculation, it's 23.4 grams. Okay, so this is the number calculated. So we call it theoretical yield. This is how much you should have got in theory if all your 15 grams of sulfur 8 reacts completely. Okay, so we have the actual yield and theoretical yield. So we can now estimate the percent yield. It's going to be actual over theoretical times 100. And that's going to be 85.8%, sorry, 85.5%. Okay, so we have done normal stoichiometry. We have also done stoichiometry using limiting reagents. So next part of this chapter, we're going to discuss about different types of reactions and then do stoichiometry on them. So you're going to see some problems where you get moles from molarity, and that will be the next part of this chapter.